Hello, everyone. Welcome to our Automotive Redefined Technology Showcase presentation on automotive Wi-Fi and Bluetooth solutions. I am Gajinder Vij, Senior Director of Product Management at Qualcomm Technologies. Wi-Fi and Bluetooth have become indispensable in our everyday lives at home and at work. I'm here to talk about how these technologies are transforming our automotive experiences. I will be talking about key use cases we see emerging, touch upon a few aspects of technology, and showcase the breadth of our automotive connectivity products. In early 2004, the first vehicle launched with a Qualcomm Technologies Bluetooth chip fully integrated into the infotainment console. Since that time, we have shipped over 500 million connectivity chips to our customers for integration into vehicles. And while Bluetooth has achieved near 100% attach, over 45% of cars and light trucks shipped in 2020 also included Wi-Fi. If you purchase a new car in 2021, it is very likely that your car will have Bluetooth Wi-Fi as an option. So let's talk about the use cases driving the high adoption of Bluetooth and Wi-Fi in vehicles. With our phones connected to our vehicles via Bluetooth, hands-free calling allows us to make and receive calls without taking our hands off the wheel. We also have access to our address books, and some cars will now read our text messages back to us and allow us to respond, all with our voice. Bluetooth is also widely used to play back music through our speakers. Our Qualcomm aptX technology ensures that we can listen to our phone audio with CD quality fidelity. Bluetooth is also becoming the link of choice in rear seat entertainment systems. Bluetooth has made a significant impact on our safety and comfort while driving and will continue to be a huge part of our in-car connectivity experience. Now let's see how Wi-Fi is also becoming increasingly important. A car can act as a Wi-Fi access point or as a client. As an access point, the car uses a 5G or 4G LTE connection to provide internet data services to devices in and around the vehicle. Once you have a hotspot in your car, you can get access to applications and use cases that you're accustomed to in your office or at home on your couch. These include familiar Wi-Fi use cases such as web browsing, email, streaming your favorite TV show, or playing online games. Wi-Fi can also be useful for voice over IP calls or video calling. And why not virtual reality? The possibilities are wide open. A rapidly emerging use case is wireless phone projection. Android Auto, Apple CarPlay, and Baidu CarLife are phone applications that connect to your vehicle and project approved content and apps onto your infotainment display. I especially like this feature in rental cars. Until recently, these applications required you to plug your phone into the car. However, we are seeing phone projection rapidly migrate to working over Wi-Fi. Soon you won't even have to take your phone out of your pocket or your purse. Now, your car can also act as a Wi-Fi client. Connecting your car to your home network allows you to have the latest software updates from the automaker. You can also receive service bulletins or recall notifications that can pop up when you get into your car. When getting your car serviced, the dealer's computer can read diagnostic codes from your car over Wi-Fi or upgrade the software on your car's computer. Doing this wirelessly is much more efficient because it can be done while the car is waiting to be serviced. All the information the mechanic needs to service your car can be available on their service computer before your car is even pulled into the service bay. I've covered the most common in-car and infrastructure use cases. Wi-Fi also enables another set of use cases that I like to call near-car use cases. If you've ever towed a boat or trailer, imagine if you could see behind that trailer. Some automakers are offering wireless backup cameras for exactly this purpose. They offer a pre-configured camera that you can attach to the back of your trailer, and when you reverse your car or truck, the display in your vehicle will show you the camera feed. This amazing safety application is possible because of Wi-Fi. We've seen James Bond drive various vehicles using his phone. Automakers are now enabling a tamer form of remote control driving. A Wi-Fi connection between your phone and the car ensures that you are near your car and actively in control. Granted, you won't be squealing your tires across multiple levels of a parking garage, but you can definitely have your car pull forward out of a tight parking spot. You may even get a car's eye view streamed to your phone from either the front or the back camera. I've covered key use cases driving the adoption of Wi-Fi into cars. Let's go through a few key aspects of Wi-Fi technology. There are 3 generations of Wi-Fi that are relevant today. When it came to market, Wi-Fi 4 was pivotal because for the first time, Wi-Fi became fast enough to replace your wired connection. At the time, you could unplug your 100 base T Ethernet connection and walk around the office and still have a good experience. Wi-Fi 4 is still relevant today, with every modern Wi-Fi device still supporting this version of the standard. Even today, Wi-Fi 4 primarily operates on 20 megahertz channels in the 2.4 gigahertz band. As many of us have experienced, the 2.4 gig band has become very crowded. The reason is there are only 3 non-overlapping 20 megahertz channels. During the previous decade, regulators began freeing up channels in the 5 gigahertz band. This opened up a number of 20, 40, and 80 megahertz wide channels. Channel bandwidth dictates how much information can be communicated between devices. Doubling the bandwidth leads to double the throughput. Now, though Wi-Fi 4 included support for the 5 gig band and 40 megahertz channels, adoption was very limited, at least until Wi-Fi 5 came along. Wi-Fi 5 offered a significant boost by increasing the bandwidth to 80 megahertz and the modulation rate to 256 QAM. Factoring in MIMO, Wi-Fi 5 increased throughput by more than 10 times over Wi-Fi 4. I'll cover MIMO and modulation a bit later in this presentation. With greater throughput and increased frequencies available, Wi-Fi 5 has quickly become the default band for connected consumer devices. Almost every phone or laptop you can buy today will support Wi-Fi 5. That said, many lower complexity devices that don't need high bandwidth still only support Wi-Fi 4 and the 2.4 gigahertz band. Think of your Wi-Fi connected light switches, connected outlets, and security systems. A note on the 5 gigahertz band. Depending on the region, use of the 5 gig band sometimes requires extra restrictions which are specific to that region. Some examples include lower caps on output power, indoor use only, and DFS restrictions. I won't go into DFS or dynamic frequency selection, as regulators have indicated that these channels should not be used for devices that are mobile, such as cars, trains, or drones. You may have heard about 802.11ax or Wi-Fi 6, which was launched over the past year. Where Wi-Fi 5 primarily focused on increasing throughput, Wi-Fi 6 also added key features to improve overall network capacity. Key features in Wi-Fi 6 include higher order modulation, wider bandwidth, multi-user MIMO, BSS Coloring, and narrower channels for IoT devices. There's a host of other improvements, over 50 at last count. Additionally, Wi-Fi 6 improvements apply to both the 2.4 gig and 5 gigahertz bands. An evolution of Wi-Fi 6 is Wi-Fi 6E, where Wi-Fi 6 extends into the 6 gigahertz band. 1200 megahertz has been allocated for Wi-Fi above the 5 gigahertz band. This new spectrum will bring in 14 80 megahertz channels, which also can be bundled together to create 7 non-overlapping 160 megahertz wide channels. The regulations around 6 gigahertz are just being rolled out, and use of this band is currently restricted to indoor or fixed outdoor installations, which rules out use in cars right now, except in the UK. The UK is the only region thus far that has authorized the use of 6 gigahertz for mobile devices. Wi-Fi is quickly becoming indispensable in vehicles, and we look forward to additional regulators making 6 gigahertz available for low-power mobile use cases. I talked about bandwidth earlier. 2 additional concepts are MIMO and modulation. In wireless communication, devices with one antenna can receive and transmit a single stream. This is known as single input, single output, or SISO. While adding antennas can increase system cost, additional antennas can allow multiple information streams to be sent simultaneously. A 2x2 multiple input, multiple output, or MIMO connection can support double the throughput over SISO. Multiple antennas also increase the robustness of the link. On modulation, quadrature amplitude modulation refers to the resolution of the signal that can be transmitted and decoded in a given time slot. The evolution of chip technologies has led to lower signal variance at the transmitters and improved receive sensitivity. More bits of data can be transmitted per time slot. In short, higher fidelity talkers are speaking to listeners with better hearing. When Wi-Fi 4 was launched, 64 QAM was state-of-the-art. Wi-Fi 5 and Wi-Fi 6 introduced 256 QAM and 1024 QAM respectively. Now let's look at what this means for performance when we pull all of this together. A 20 megahertz wide link at 64 QAM can transfer at a peak rate of 72 megabits per second in a SISO configuration and up to 144 megabits per second in a MIMO configuration. An 80 megahertz wide link at 256 QAM can support up to 866 megabits per second in a MIMO configuration. Wi-Fi 6 with 1024 QAM in that same 80 megahertz can support 1200 megabits per second. And when you're using a 160 megahertz wide channel, that can go up to 2.4 gigabits per second. I've talked about some of the foundational technology elements of Wi-Fi. There's an additional factor to Wi-Fi chips that is relevant to automotive deployments. Depending on the generation, Wi-Fi chips can operate in the 2.4, 5, or 6 gigahertz frequency bands. Single MAC chips can select between these bands, tuning to one band at one time. Single MAC chips can also support SISO or MIMO. Dual MAC chips have additional logic to support concurrent operation on two different bands. This is known as dual band simultaneous. Consider the use cases we discussed earlier. With DBS, a wireless backup camera can operate without interfering with a passenger that's streaming video to their tablet. DBS solutions offer greater overall throughput, support more clients, and support greater concurrency modes. I've covered how 1024 QAM results in greater physical layer throughput. Wi-Fi 6 also supports longer symbol lengths. Longer symbols means that Airlink protocol overhead is smaller as a percentage of the overall packet size. Less overhead means more room available for payload data, greater effective throughputs. Another key enhancement in Wi-Fi 6 is called BSS Coloring. Wi-Fi is a listen before talk technology. Before a device can transmit on a channel, it must first listen to ensure no other device is transmitting so that it doesn't step on the ongoing transmission. There's a regulatory threshold where if the detected signal is low enough, a device could choose to transmit, but in practice, this creates problems for devices that are far away from their access points. The paradigm thus far has been to avoid transmitting over any Wi-Fi signal that can be detected. BSS Coloring tags packets with the identity of the access point network that they are associated with. When a device is ready to transmit, it can determine if the competing signal is from a device on its same network or is associated with a different network that may be far away. If the signal is low enough and from an outside network, the device can choose to transmit anyway because there's little chance of interfering with the other link. Consider if your passenger is streaming a movie over your in-car hotspot and you pull up to an intersection. Now imagine if another vehicle across the intersection is operating on the same channel. Under Wi-Fi 5, that interference would cause you to reduce your performance. With Wi-Fi 6, the network in your car can ignore the interference from the other network, improving overall system throughput without impinging on the other network. Now, I've touched upon just a few aspects of Wi-Fi technology, but let's talk about how Qualcomm incorporates these advances into products for our automotive customers. The QCA6696 is our leading automotive Wi-Fi solution. This chip supports 2x2 MIMO, 80 megahertz wide Wi-Fi 6 connections in 5 gigahertz, fully concurrent with 2x2 MIMO, 40 megahertz Wi-Fi 6 connections in the 2.4 gig band. QCA6696 can support almost 1.8 gigabits of physical layer throughput. It includes Bluetooth 5.2 with many optional features, including BLE long range. The QCA6696 can be deployed in a 3-antenna configuration where it can support Bluetooth in parallel to 2x2 MIMO and 2.4 gigahertz. This chip is included with the Qualcomm connected car reference design. The QCA6696 is already being designed into multiple car programs that will be launching in 2021 and 2022. Now, we weren't satisfied in simply releasing the most advanced automotive Bluetooth Wi-Fi solution, so we also developed the QCA6595AU. This product updates Wi-Fi 5 to create a high-performing and economical option for mid-tier vehicles. The QCA6595AU allows automakers the options of delivering an excellent Wi-Fi experience in vehicles where advanced concurrency modes aren't necessarily required. A key aspect of this solution is support for a 2-antenna configuration with Bluetooth and 2.4 gigahertz SISO Wi-Fi on separate antennas, while 2x2 MIMO 5 gigahertz utilizes both. The MIMO 5 GHz delivers excellent throughput to smartphones, tablets, and laptops, while SISO 2.4 GHz Wi-Fi is available for supporting legacy devices. Bluetooth and 2.4 gig Wi-Fi can operate with minimal conflict when there's sufficient antenna separation. The QCA6595 is already generating great excitement from our customers and will be launching commercially in vehicles later this year. With the addition of these new chipsets, Qualcomm Technologies now offers a complete portfolio of automotive Wi-Fi Bluetooth solutions. The QCA6696 and QCA6595 complement the QCA6574AU, our single MAC MIMO solution, and the QCA6564AU, our single MAC SISO solution, both of which are already shipping in volume to automotive customers. When we decided to expand our portfolio, we understood that more options could lead to more software complexity for our customers. To address this concern, we developed our new chipsets under a unified driver framework, which supports our entire portfolio of solutions. Automakers and their partners can develop on top of a single framework and pick and choose which connectivity chipset meets their needs for a particular program, without having to go through a full software integration if they change their Wi-Fi chip. In addition, our driver is already pre-integrated into the software products for the latest generation of Snapdragon Automotive Compute and Snapdragon Automotive 5G and 4G LTE solutions. Qualcomm Technologies has been a major contributor to advancing the state-of-the-art in Wi-Fi. Notable contributions include 11AC multi-user MIMO, 11AX OFDMA, distributed Wi-Fi, also known as Easy Mesh, and multi-gigabit 60 GHz 11AD. We have a broad portfolio of Wi-Fi and Bluetooth solutions that are deployed across mobile, infrastructure, compute devices, and also in numerous IoT installations. With our Wi-Fi leadership across multiple segments, our pioneering technology, and our 30-plus years of leadership in the mobile industry, our team has been able to develop one of the broadest portfolios of automotive connectivity solutions available. And this is just one aspect of the amazing technology we are bringing to the automotive industry. Thank you for spending some time with me today